Why don't we start with explaining the difference between a function and a procedure? Okay, so Yina, do you want to explain that a little?
All right, okay.
If you're talking, I can't hear you. Yeah, I still can't hear you. I'm not sure if it's just my Wi-Fi. Oh, never mind, I can hear
Are
you.
we good now? Okay.
Yeah,
So
we're good
if
now.
I recall Chapman's grade 11 class correctly, I'm pretty sure a function is what returns a value for you that you can use later on in your code, and a procedure is just like a block of code that you want executed.
Yeah, that's true.
Right? Okay. Well, let's
returns.
for like the sake of ease, I think we're gonna use the name function to refer to both, just like as an umbrella term. But if Chapman ever asks you what's the difference, that's basically the difference.
Yep.
So why do we need? So why do we need to use?
Yeah. Let me just quickly add something. This is just like a little nuance thing. Sometimes, if you're like rushing, you might just call a function or procedure accidentally, or we might accidentally say it, and it doesn't mean we are wrong technically, but it's just like it's just a little nuanced kind of thing.
It doesn't really matter that much. I usually just use functions just for sake of use. All right. So let's talk a little bit about why we need to use functions. Well, when we have a certain okay, let's say we're doing a math assignment, and let's say we're calculating slope, right? Let's say this calculating slope operation, this whole little arithmetic procedure, this is something we're going to need to do over and over and over and over again in our larger piece of code. So maybe your larger piece of code is something like a graphing calculator, which you actually have to do in grade 11 CS. So calculating slope is like something that you're going to do a lot. So wouldn't it be a lot easier if we kind of found a shortcut? And instead of doing something like, enter, like x1 equals input, like x2 equals input something divided by rise divided by run. Instead of doing that every single time we need to find slope, we can use something called a function and kind of give Python like a template and let Python store that template so that when we need to use it, we just say, hey, Python, calculate slope for me. Like, here are my values. And then it can just do it a lot faster than, it's a lot faster and more efficient than writing that whole, here's rise, here's run, every single time you need to use it.
Exactly.
Functions are really useful when you have a certain block code you're going to need to execute multiple times during your larger program. It's kind of like a shortcut or like a quick template.
So let's just give a like a quick an example regarding that slope thing. So if you had to actually calculate the slope in a code, you have to use the you can figure out the rise value, the run value, y2 minus y1 over x2, all that stuff. And obviously you'd have to type it out and it would take a long time, right? But what if you had to use that multiple times throughout the code? Wouldn't it be a lot easier if you had a function that was just called slope and you enter the values like in here? Just enter values and then it would give you the slope for you. In that case, you wouldn't have to actually do all those calculations every single time. So that's what a function is.
So before we can actually use the template, we have to make it. We kind of have to give Python that toolbox before we can actually call upon it. And like all things when we're coding, we have a specific syntax to do that. Michelle, you want to show me?
Yeah, okay. Let's say we wanted to make a function that printed out hello onto the screen. So the way you do that is you start with def. Def means, I think it's short for definition. So define. You're giving them the definition. Oh, define. Yeah. Same thing. So you let's say hello. Oh wait, is that yeah. If it turns purple, it means I think it recognizes the function now. Actually, let's say print hello. Actually, let's say hello. Let's just be fancy. Okay, so when you do this part, Python reads this and it says def, and it's like, oh, so they're going to give me a little toolbox here, and say hello, and these empty brackets, you can put something in them. We'll get back to that later on, but let's start with empty brackets for now. And in say hello, we see notice there's an indent, so that means that whatever you put inside the indent is going to be run in say hello. So we wanted to say hello, say print hello. So that is the function. So now we have a defined function called say hello that prints hello. So now if we want to run it, all I have to do is this. See if that works.
Yeah.
So that works, yay.
Yay. So do you want to actually get rid of say hello and Oh no, the second one when you call it.
Oh,
And
okay.
does anyone know what's gonna happen when we run this?
Yeah, type in what you think is going to happen. Yeah. Oh wait, that's French for nothing, isn't it? Yes, that is correct. Nothing is going to happen.
Yeah, nothing's gonna
However, even though nothing happens in this actual section, something did happen when you ran the code, and it's that Python added this to its toolbox.
Yeah.
So something did happen, but nothing, you don't really see it happen. That's right. Okay, so let's say we, oh, no, that's very, let's say we say hello now. And what if I wanted to make it say hello and a name? So in this case, here's, okay, another thing that functions have is something called parameters. And parameters is what you put inside these brackets. So you can name them anything you want. So let's say name. Why is it in italics? Oh, there we go. Wait, why is it in italics? Is that just another feature? Whatever. Okay. So we have name. And in this case, when you put, okay, so whatever you put in the function here, it has to match up with this. So if I say name in here, I have to match up in here with name. So my name is Michelle, so let's say I put Michelle. In this case, I want to use this. So I can do hello plus name. Pretty sure that's how it works. All right, let's try to run it. It works, but let me fix this because it looks ugly. And okay, I kind of went through it a little quickly. Let me just reiterate through it. So when Python sees this, it says, oh, this is another toolbox, and it's say hello, and in the brackets, you need another thing that the user actually gives you, and it's a name. And within the definition of the function, you use this thing called name in the actual thing. So you have to use it here and here. And when you're running the function, just to say hello, you have to enter it to replace.
Mm-hmm.
So it's kind of like a variable.
Yeah, I guess the way you could describe a parameter is a variable that exists for the purpose of your function.
Yeah, it would also, another important thing to remember is that this exists within the function only. Mm-hmm. So if I said here print name, I did this, it wouldn't be defined because name is only defined within this single function. So it's not defined outside of the function.
Yeah, so that's kind of what makes it different from like your traditional variable. So when we use a parameter, it's basically, it's kind of like, what's a good way to describe this? You need to make a variable just for the sake of running your function. You don't really need to use it for anything else.
All right, nice.
Mm-hmm.
So let's add on to this. What if we wanted the user to input the name, and we wanted the function to print out whatever the name was inputted? There's a few different ways to do it, but I'm pretty sure you guys know. Okay, so let's say, yeah, I'm pretty sure you guys know. We've done this many times before. Oh, and also another good thing about this is that now I can reuse variables. Like, it's probably not a good idea, but if I do this, nothing's going to happen because this is only defined within this function, so I can reuse it outside of the function, and they're going to be two separate things. Let's say name input. What is your name? Then, instead of saying Michelle, I can give them whatever the name is. And I don't actually have to do this. I can just delete it because the print function is inside this. So let's say this happens. Let's say my name is Yina. And it works. Yay.
Wait, sorry, Michelle, did you talk about calling functions?
Calling functions? I mean, this is basically it, but like you can go depth if you want.
Yeah, sorry. I just wanted to like reiterate that when we have say hello and then bracket with whatever argument we're giving, that's basically called calling a function. It's, I guess, just like terminology that will be handy for you guys. So defining a function is telling Python what the function is. Oh, that's some.
Is someone unmuted themselves? Oh, Yina, can you mute yourself, please?
Bir saniye.
Or whoever it was. All right, we're fixed. We're good.
Okay, are we good now?
Yeah.
Okay, yeah. All right, where was I? All right, defining a function is telling Python what your function entails, telling it what to do, and then calling your function is actually telling Python to execute that code. So you're not gonna get anything like outputted if you don't call your function. That's just like sometimes I know
Yeah.
like personally sometimes like I'll make a function and I'll forget to call it when I actually need it. So yeah, make sure you call your functions if you actually want to use them.
Yeah. Okay. Another thing that's really important. You have to put the actual function definition before you have to define the function before you call it. It's pretty intuitive, but like sometimes if you move around a lot of code when you're trying to debug, you forget about it and it just doesn't work. So like say I call it first and then I'm like, wait, I should define it. So I define it afterwards. Oh wait, does it still work? Hold on. Nope, it doesn't work. Oh yeah, because this is just a random input. Okay, so in this case, because Python runs line by line, so what it does is, oh, I get the name, and it says say hello, and it's like, I don't know what this is, because I don't have it in my toolbox yet. So you have to define it beforehand.
Yeah, and I'm sure
okay.
I'm sure by now you guys are like already used to it, but remember Python reads line by line, so can't be referring to any variables or functions before you actually define them.
Oh, top to bottom. Yeah, line by line, close enough. Okay, do you want to move on to return?
Oh yeah. So remember when we were talking about functions and procedures? Like the say hello, what we were playing around with that's actually a procedure, but I'm just gonna be using function for both of them unless I actually need to specify the difference. But returning
here's where it gets off.
Yeah, returning is when we actually
keep on.
Get a certain output from a function. So it's kind of like I guess it comes really in handy when you have functions calling each other and you need the return of one function as a argument for the other. And that would make more sense.
Okay,
actually.
So we're just going to keep on going, and if you have questions at the very end, you can ask us, but right now it might seem confusing. We just have to show it to you, and you might be able to understand. So right now, this is actually a procedure. We just call it a function because that's just like the general, easier term, but if you want to be really picky about it, this is actually a procedure. It's a procedure because it does something. It doesn't return a value, it prints this thing onto the screen. So it's like this procedure. And a function actually returns a value. And in this case, let's say instead of printing this out, I wanted to make this into, I wanted to, I actually wanted to return it. So in that case, you would write return. I think that's how you do it. And in this case, instead of just running the function, you would have to print it. Oh wait, here's an easier way. Let's split it off. Greeting message equals say hello with name, and then you print the greeting message. Okay, let's just run this first, see if it works. Let's say your name is Jack. I don't know. This is fun. See? Okay, so that still works. And however, it works in a different kind of way because instead of a procedure, it's now a function. So functions have a return. So, do you want to run through how this return thing works?
Oh, okay. So, I guess like the most straightforward, easy to understand way to explain it is kind of when after you call the function called say hello, it kind of like the value of say hello turns into hello plus name, whatever you return it to. So in the case where what we had before was define say hello colon, and then we had print hello plus name. In that case, that was procedure, and we didn't actually return anything. But sometimes we don't want to print our whatever is in our function. We don't want to print it right away. Sometimes it's like number, and we have to use it later on in the code. So returning is kind of like storing the value of that function for that specific argument.
So in this case, when Python sees say hello name, it goes up to this function. So it sees this and it says, okay, so I do this and I return hello plus name. So in this case, hello Jack. So in this case, it takes hello Jack and it replaces wherever I called the function with whatever the function returns. So I'm going to say that again. It replaces wherever I called the function with whatever the function returns. I think that's a good way to say it. So it just replaces. So instead of say hello bracket name, it would be like hello Jack. It would be that instead. So it replaces it, and then I can print it out, and that's why it works. All right.
I'm sure. I think that was pretty straightforward, but
Yeah, if you guys
once you start using functions, you get the hang of return. Return. I feel
yeah.
like you use return a lot.
Okay, what if we just run through from our examples so they get more comfortable with them?
Yeah, let's do some returns with like numbers, like math.
Yeah.
Because I think that's like
Oh my
at least
gosh,
for
why
me,
is
that's
it
like
always like that?
that's where I use functions a lot.
Yeah. Okay, let's say we wanted to calculate let's go back. Let's go to slope. Let's do slope. Okay. Write a function that calculates slope when given y1, y2, x1, and x2. Let's see if I remember this. Okay. So
Wait, before we go. Okay,
yeah?
never mind.
Yeah.
Before,
Sure.
does anyone know? Like, just anyone remember the format that we have to do it? How to define a function? I think Michelle already started, but
Yeah,
just gonna drill it into your brain.
yeah. Like, how would you start it? And if anyone remembers the slope equation, drop it down in the lesson room chat because
Yeah,
I
just,
don't think I remember it.
It's just y2 minus y1 over x2 over. Okay, it's fine. But does anyone know what we should do like right now? First line.
Yeah, someone just drop the first line down in the lesson room.
So we want to define a function that calculates slope given 4 values.
Mm-hmm. If no one knows, that's okay too. We can just keep on moving.
All right.
All right, let's just keep on moving.
Actually,
Someone's typing.
Yeah, you start with def.
Yes, you're right.
What else do we need to do?
Okay, yeah, so we have to. Okay, let me wait.
Okay, fine. We can just move on.
let's just move on. I'm pretty sure they know. They're just too scared to say it, which is totally valid because I never raised my hand in class either. All right, so def. We can call it whatever we want as long as it should be like valid. Let's say like
get slope.
Yeah, get slope. And you're given these values, so you know you should be able to use them inside this. So we should actually give them little parameters inside. I think it's a new thing that italicizes it for you. I don't know why, but
Nice.
I just feel like that. Don't forget the colon. That's a very big thing that I always forget. Okay, so you have these values. What is the equation? Slope is equal to, what was it, y2 minus y1 over x2 minus x1. I think that was it, wasn't it?
Mm-hmm. Also, wait, Michelle.
Yeah?
Int.
Oh, right. Wait. How do we do that again?
It just turns into int.
like that? Wait, no. It was a thing where, okay. Isn't it the thing where if you divide two things that aren't, don't we have to like make them to floats because otherwise they just round down?
I guess. Hold on.
I think that was that. Let's try. Let's see what happens. Okay. Do you want this to be a function or a procedure? We can do either. Let's make it a
let's
function.
Do function. Yeah, because I think we want to get used to using return.
Okay. So in this case, we have return slope, and now let's say new slope equals get slope with, I don't know, 5, 2, 3, 1 random numbers, and then you print the new slope. Okay. I'm not sure if this will work.
I don't think it will, but it's okay. We can debug as it goes.
Yeah. Please run. Please. Okay, let me just restart. Okay. Oh,
no.
nah, it might actually work. Never mind. Maybe it was something with whatever. We'll see. Okay. Okay. So it's 1.5, and wait, let me just do some quick math to see if that's true.
Quick maths.
3 over 2. Yeah, no, it is 1.5. Okay, cool.
Okay,
We're good.
good.
Nice. Okay, so as you can see, functions can work with either strings or integers, and you don't actually have to, well, with Python at least, you don't have to define whether these are integers or strings because it's the code's just going to take what you get and it's going to do it. But, well, obviously you have to make sure they match up too. Like if you write like hello, it's not going to work.
Hello.
It's unsupported. So yeah, because they're like, I can't add hello with a number. So as long as you make sure they match up, you'll be all good. Okay, so here's a get slope. What if we wanted to?
Wait, let's think of an example where
you actually use the return function.
Yeah, I think that's most useful when like you need to use functions like one after the other. Or like you need them to call each other.
Yeah, okay, so what can you use with slope? What do you do after you have slope?
I don't know. It's been a lot.
I guess it could be the equation. Yeah, okay, if you have a slope of a line. You can do like y equals the slope x plus b, I guess. You can format it like that.
Or you can say like
okay, actually no, let's do that. Let's do that. Write a function that formats an equation in the form y equals slope. No, I'm just gonna write mx plus b, where m is actually calculated. Okay, so we have to figure out this now.
Grade 9 flashbacks.
Yeah. Oh wait, someone asked a question.
Oh, let me check.
Okay, can we use user inputting the y's and x's? We can totally do that. We can do that in a second. If slope is 10 over 3, how would you round to 2 digits without removing the decimals, like actually rounding?
I think there's a round function, right?
Yeah, I think there should be a round function. Yeah, it is. So like, I don't know, number equals 14 point. Let's just test this out really quickly.
And then I think the parameter is decimal places. Yeah.
It looks like that. Wait. Oh, print. Oh my gosh, I have to print it. I forgot that. This isn't about functions. I just wanted to answer someone's question really quickly. It's a little, and it might be useful in your little toolbox. Round is a built-in function. Does that work? Wait, that doesn't. Lincoln places too. Yeah, that works. Okay.
Yep. Okay.
So it's the whatever you want to round and the number of decimal places. So there you go. Yep.
Okay, cool.
Okay. Someone else asked. Yeah, no problem. Annika asked, could we use user inputting the y's and x's? We could. Let's do that after we do this part actually, because then we can have like a little cool calculator thing. Okay. So write a function that formats an equation in the form y equals mx plus b, where m is actually calculated. So once again, def. So we're adding another function. It's called format equation. And let's use, all we need is the slope. The slope is the only thing that.
B, right?
Oh,
B.
Okay, yeah. Oh yeah, you're right. I totally forgot. Okay, yeah. So we have the slope and b. Listen, I haven't done math in too long. All right. So we have two things we could do here. Actually.
Well, first of all, you can do slope equals.
Slope equals. You have to get slope with these values, but you'd have to use these values then. Okay, no. Okay, here. Let's say
actually,
we need to write. Let's say we don't have slope yet. We only have these values. Is that how it works?
Wait.
I think it works like that. It works like that.
It's been a while.
Yeah. Okay. Let's try this first. So instead, we're trying to make this like a huge function that kind of has this function done within this function. So you don't actually have the slope. You only have these values. So what we have to do, we have to actually use a function within this function. So we're going to, and you have to make sure to match up everything.
Yeah.
So right now, so these variables that we have, they're going to match up with these, and they're going to match up with these.
I think it'll make more sense when we actually run through it.
Yeah. Okay, so we have this. So after you calculate the slope, you can print it out in that format. So it would be y equals plus slope plus x plus b. Oh, and once again,
Yep.
do not forget. Very important.
I feel like I actually don't do that a lot because I always use commas.
Oh, I use pluses just because they don't add a space, and sometimes I want that. Like if you use commas here, there would be a comma between the number and the x, and that just bugs me. So I want to be in control of everything. All right. So now we have this. Let's see if. Okay. So in that case, instead of a slope, we're going to say new equation. So new equation. Say we have what points do we have? Let's say we have a line with the points 5, 3, 6, 2. And oh wait, and since okay, also make sure you match up the number of parameters, which how much you're inputting them. So let's say these are the points, and our b value is the y-intercept. Let's say the y-intercept is like -3. Okay. So if we run this, let's see if it works. Oh, it doesn't work in valid syntax. Oh, I wrote it wrong. Yeah, there we go. It still doesn't work. Hold on. Oh, there you go. Hey, okay. The reason I had that bug was I just forgot. Okay, this is also a super important thing. You have to make sure you have enough brackets, and sometimes a little helpful tip when you have a bug. Sometimes it's not on this line; it's on the line before. Because if you're noticing back then, if I was running this, it kept on saying that the error was in line 17, but this was actually right. It was just because in line 15, like in the line before it, I was missing a bracket, so it automatically went on to the next line. It was like, there's an error here.
Yeah.
So sometimes if there isn't an error in the line, look on the line before. And in that case, I did have an error in the line before. And now that I got rid of it, it works.
If you have a missing, that's usually the case when you have uneven parentheses. If you're missing the last parentheses, basically what Python thinks is that like all the code after your parentheses is actually included in like the whatever function or whatever parameters you're setting, like whatever's in between the brackets. So it's just like, wow, that's a lot of stuff to put inside the brackets. Anyways.
Yeah, exactly. Okay, so let me just quickly run through what this does. Okay, so
before you do that, I just want to quickly announce that attendance is open, so make sure to go over and do that.
Yeah.
Yep.
Yeah, go over and do that. But first, look at this first. So let me just explain this and then go do attendance, or you can just.
Wait, Michelle,
that's fine too. Oh, I did. Again.
Oh, okay. Wait, maybe my.
Okay, so. Yeah. So right now, so let's say we're starting from the very beginning. So Python, we run the code. Python looks at this. Oh, it adds this little slope function to its toolbox, and then it sees this and it adds the little format equation into its toolbox, and it doesn't do anything with it yet. And then it gets to this with the format equation. So it sees format equation, and it's like, okay, I actually know what that is because I just added it to my toolbox. So it goes back to this function, and yeah. So to run this function, you need these 5 values, which we actually give Python in here. So it uses these 5 values. In this line, okay, so it says, okay, I need to know the slope. So I need to use getSlope. And whoa, look, I actually know what getSlope is because I added it to my toolbox. Wow, incredible. So it gets the slope using these values that we did give it. And so it does that, and this is when return comes in handy, because instead of printing it, you're actually using that value here, because whatever you return, which is the actual slope, it's just going to be defined as the variable slope over here. So now I have the slope, and now we can print it out. So now we print this. And that is the final equation. And that is done within this function. And obviously, if we wanted to make this an actual function instead of a procedure, or make it return instead and print later on, we can do that as well. But usually, this is just simpler if we do it this way.
Well, I think it's important to show you guys like the way we do things, like using simple examples, because when you get to like, obviously we're gonna do it as like part of the lesson too, but once we actually get like longer pieces of code, it's important to know how to use these tools and like how to use functions most efficiently.
Yep, it's gonna get a little more complicated next lessons, but for now, this is the little general toolbox you need. I think, and let's make it so that the user inputs these. So in that case, we can just say y1 again, because these variables are only defined within the actual function. We're allowed to use them outside, which is also it's super nice. Y1 equals. It's super useful when you have like a billion variables to keep track of, and you don't want to make a different one each time. They only exist within the function, unless they're global, which you'll learn about maybe in grade 11 CS. Okay, there we go.
Awesome.
And now, and the b value. B equals input.
I can't see your stream right now, so I have no idea what you're doing, but I trust
you.
you.
Can't? Oh, I'm just writing an input statement for each of the values.
Yeah,
y1, y2,
sure.
x1, x2, and b. All right, let's try this. Let's go a little crazy. So hard. Hang on, let's see. I'm prepared to operand type for a string. Oh, okay, that was a dumb mistake. These are all strings. I have to make them integers. If we're doing math with them.
SMH Michelle. After all that
Dude, I literally always forget about this. I'm not. And that's why you have to remember. Yeah. Okay, there we go. Okay, listen, they're integers, so I can't use decimals. I forgot about that. Oh my gosh, division by 0. When do I have 0?
I have no idea what's going on your screen right now, so
No, hang on.
Format equation y1, y2, x2, x2, b on line 22.
Oh my gosh, you're right. Okay, thank you so much. You have to, yes, whoever spoke up, thank you very much. Yeah, that was my mistake. Oh my gosh, okay. Yeah, it works. Okay, finally it works. All right. Obviously this is like a huge ugly number. Oh, and actually, let's actually round slope equals round slope 2. See, now we're bringing it back to what I said earlier on. We can just round them instead. And in that case, okay, so now it's a lot neater. It's not accurate, but it's a lot neater. That works too. We can do that. Awesome.
all right. So let's just sum up a bit about what we talked about today. So functions are useful when you have when you want to add a certain tool or a template into like your whole arsenal when you're coding. So it's basically when you have like a certain operation or a certain just block of code that you want to execute over and over again. So you want to make it efficient and kind of create a template. So you can just say, hey, Python, do this with this number. And then you can do it immediately and quickly without you having to like write the whole like block over and over and over again. To begin with functions, we have to define functions. You do that by typing def, function name, and then any parameters you want to use, colon, and then indent everything else you want to include in the function. And when we actually want to put to use our functions, we have to call them. Other than that, yeah, you can use functions within each other, which we talked about today. And I think that's basically what we covered.
Yeah. And if any of you guys are doing math right now and they give you two different coordinates and they tell you to find the slope, you can just use a piece of code and you don't have to actually calculate it.
All right. And we learned about return, which is really useful. It's kind of like when you want to store whatever value the function is calculating.
Mm-hmm. All right. If you haven't done the attendance, do it now. That's basically just the generals of what functions are. It's just a little thing. Next week we'll be delving more into some more useful stuff about functions.
Yeah.
Functions are incredibly useful. Like they're probably like it's a very, very important foundation. You should know.
Yep.
Awesome.
So yeah, make sure you had two general announcements, right?
Mm-hmm.
Yep. Yeah. Make sure you have
Should I
and react.
let's try to think of let's try to think of a little cool challenge question. Let's do. Okay, let's say write a function that tells you your average when given for. Listen, I can't. Different marks. Yeah, there you go. That's kind of a boring example. I'm sorry. If you have any ideas on how to write a more interesting function, feel free to write a more interesting function and share it with me. I will be delighted.
Yeah, just write a function.
Yep. Yeah. There. Never mind. Your challenge is just to write a function. That's your challenge. Write a function. Any function. Have fun.
The more complicated I'm just kidding. I'm gonna give you guys that challenge.
Yeah.
Really
Yeah. Honestly, you can just write a function that's like print hello and it prints hello. It can be as complicated and as uncomplicated as you want. And that's the beauty of functions. All right, that's the end of our lesson for this week.
Next week, this is kind of just an intro. It's kind of like giving you the basic knowledge structure that you need to use with creating functions. Next week, I think we're going to delve in a little bit more about applications. So yeah, have a good week, everyone.
Yeah, and good luck with all your schoolwork.
I just had a quick question.
Yeah, of course.
So when I was running the code, right, so that I just copied it over here. And so what if for B, you give the input of like a negative number, so it would always print out like X plus 2 kind of thing.
Yeah, that's very true. Okay.
Yeah, I think we were taking like a lot of ugly shortcuts with that function. But yeah.
Yeah, you're right. It says
you definitely need to account for like all of those tiny cases, right? Because like
Yeah.
what if B is 0?
Oh, right, yeah. There's a lot of different things. But, okay, just a really quick thing. The way I would solve this is, inside this, I would say if B is smaller than 0, then I would print X and then nothing, because the negative is already in there, and then else I will just print it normally. So, yeah, but also you have to think of, like, what if B is 0 then? What do you do? What if the slope is actually 0? What do you say? Like, there's a lot of, like, small little things, but just for this one, like, just for this tiny little exception, the way I would solve it is, I'll do that. I think that works.
Yeah, so when you're, like,
there we go.
Honestly, I feel like a big pattern is, like, a lot of times, negatives, zeros, like, those cases are going to give you grief, so you have to use, like, if, else to account for those.
Oh, yeah.
But yeah. Not a huge deal.
Fun thing. I think this is actually one of the challenges, one of the projects assignments I had to do for grade 11 CS. So
yeah, me too, actually. I mean,
so that's a little thing to look forward to. Yeah, this is a super basic piece of code. There's a lot of exceptions. Like, what if slope is 0? What if slope is 1? I don't want to say a 1. I just want to say mx then. What if b is negative? What if b is 0? Stuff like that. So you would need a lot of if-else statements, but just for now, we're just assuming all of the integers are pretty easy. Yep, but that's it for.
You know what? Why don't we make that a challenge? Account for all like the special cases.
Yeah. Okay. Yeah. Challenge. account for all the special cases, negative values, 0 values, slope equals 1, or x not 1x, and much more. Okay, awesome.
Okay. I have another meeting to actually run to. So have a good week, everyone. Maybe if this topic is interesting to you, maybe you can do some extra studying before we delve deeper into it next week. And yeah, I'll see you guys
Yeah.
next week.